Well, gentlemen, we all are here to check out RO number 57, which is an ALS 500. Yet again, another ALS 500. The gentleman that owns this amplifier does not know if it works or not. He bought it without having a power plug for it. It came with no plug. And he's not interested in going back to the Clinch-Jones way of things. So his first question that he's got is, does it work and how much is it going to cost to get it repaired? So I looked at this and went, well, shit, don't know. I was fortunate enough that I did a modification for a guy here not too long ago on his ALS 500, and we converted the Clinch-Jones plug over to an Anderson clip. And so I saved all those parts, and he said he didn't want them back. A lot of the guys want them returned. So I built this. This is my Clinch-Jones to modern day plug adapter. It's no joke. Running just a little bit of the American Standard and Mesa cable 4-gauge wire here. And in here I've heavily modified this plug to carry as much current to the plug pins as we can get. We did change a couple things. Like on the ground side, I can only use these 3 pins because I have to keep it stock. And then we use these top 4 pins because we have to keep it stock. If we notice on the inside of our Clinch-Jones plug, we can utilize the top 4 plugs because they're basically, we only use 2 on this Clinch-Jones plug setup. Boy, that ground looks a little iffy, and so does the one on the other side. But we've got our remote turn-on wire that's right here, so we can utilize these bottom 3. So we can't utilize the bottom 4, right? The idea is to get as much current from our plug adapter to here. Now, what I could have done, and what I kind of think maybe I should have done, was just go ahead and put some 4-gauge wire coming out to some eyelets and hook it up to my workbench. But me being me, I like the Anderson clip and the twist lock leads. So I went ahead and gutted out the plug, modded the plug, and set it up for an Anderson clip. That way, if I needed to, I could use this in a pinch in somebody's vehicle. It makes this a little bit more flexible than if I just had leads that went over and we hooked up on the workbench. So if we take our 1/8 gauge Anderson clip, which you guys all know my affection for these things, how much I dislike them. I don't care for Anderson clips. It's a lot of juice to be moving through 2 contact points that just touch each other. Or our twist lock lead, we can insert, thrust, repeat, and it locks it in place, and we get a lot more surface contact and a lot more pressure. I got a lot of Anderson clips because I do a lot of modifications with Anderson clips. Guys love these. So this is more of a standard thing. This is the way I used to do things. I'd take 2 strands of 8 for the positive and the negative, and I'd bring them out through the stock hole, and then I'd bring those to an Anderson clip that we'd set like 1 inch away. That's where we started. Now we're doing panel mount conversions and all this other stuff to them to get a few more watts, help keep the voltage up, and well, you're going to see all the mods on this one because this guy wants the whole kitchen sink and twice on Sunday. So we're putting chokes on the positive lead. We're doing a bunch of stuff that should have been done by MFJ and the original designer of the amplifier, but never happened. This was great for 1980s. We're not in the 1980s anymore. 40 years ago, yo. Almost 50 years ago now. So we're going with modern times. This is our best retrofit, and this is our best workaround plug that's going to be the most commonly used. That's the reason we went this direction. Let's put this onto here, this into here, and let's get some power wires hooked up, foot pedal and that kind of thing. And let's determine if we need to fix any of the transistors. Which I'm telling you, with years of experience of looking at these now, and man, I've modified a lot of these. A lot of these. I don't think we're going to have any problems. One of the other modifications that I'm looking at getting done and having manufactured is this is an 820 and this is a 350. So there are metal based replacement 1150 picofarad caps that we make that are made, I said we, that my friend has manufactured for all of us in the radio community to use from a company out of the Middle East. That's as far as I should go. I shouldn't even drop their name on video because then everybody and their brother is going to blow them up and it's going to irritate and cause problems. But we have access to 11 and 1200 picofarad caps. And I think that's the next mod that we're going to do is we're going to start removing these polymer based caps and we're going to go to metals. A lot less chance for breakdown, like a lot. Metal is always better than polymer. Even though this has worked, we've figured out ways to do things better. This is a later model of Ameritron. We know this because of the network cable style plugs. We don't have a birth date. We don't have a serial number. The sticker has been long since removed. So this is a good candidate for super modifications, and we're going to do everything that we can possibly think of throwing at this. And yeah, let's get on with it. Well, I'm here to tell you one of the things we're going to do is we're going to replace these PL259 connectors because that, if it's making contact, it's barely. God, the same thing with the input. I mean, they are just, I should not be able to bend that down that far. I mean, that one is loose. That itself could lead to all kinds of problems. So one of the things that we definitely need to do is we're going to need to replace those panel mount connectors for sure. But we'll do that here in a minute. Let's see if we can get it to operate. All right, let me grab a foot pedal and let's get set up here. Okay, so let's turn the amp off. And we'll see that our idle voltage here on the biasing circuit side of things went to 0. We have a 1000 watt slug and peak, 1000 watt slug and average, 1000 watt slug and peak, 5 watt slug and reverse back from the Bird 10,000 watt dummy load. We're currently sitting on 12 volts, and you're going to notice in this video that this volt amp meter changes. Today is the day that I actually go over to the new display and managed to screw this one up as well. The amp portion of it is not reading proper, so before we put the new display in, we're going to put a whole bunch more choking and caps and stuff on stuff on stuff on stuff, and hopefully we'll be able to stay out of the electronics in this one and not kill it. Okay, back to on topic with this. So our idling voltage is 0.339. Now what we're looking for is when we step on the pedal, this to increase to roughly about a half a volt. So somewhere around 0.6, 0.55 to 0.6. A little bit high at 6.1. Let's take a look and see what parts we've got getting hot inside the box. Voltage regulator and these two relays are getting a little warm. Of course, we've got it set on 80 meters at the moment. This all looks good. I feel very comfortable about this. Okay, that all checks out. I have a feeling this is going to make a little bit of power. Okay, so we're on AM. We are in the middle of the 80 meter band. 1111111. Got this set up for 1 watt. Hello, audio. So our base carrier is 1 watt. Now, if I step on foot pedal, oh, that's not a good sign. Okay. Let me double check I got the band selector on the right frequency. And I do. This is not looking good. Let me show you what I'm seeing over here on this side of the street. So 1 watt carrier going in. Step on the pedal. Infinite SWR. So we're getting the exact same amount of energy back that we're putting in. 1 watt going in. Zip coming out. So let's take a look down here at the FLIR. Let's go ahead and we'll energize the transistors. We've got nothing. Nothing. So either we have a problem in our relay, which we very might well have. Let's make sure our trip light's not on. It is not. Okay, so we've got some bigger problems that we got to go look at. We have to ask ourselves, was it hooked up backwards? What happened? Let's dig into this. Okay, so this is just like the Metron that I just went, or the Worthmore amplifier I just went through. And I explained all the different circuitry. It's the same circuitry here that's in that Worthmore. This is our input attenuator, and this is what hides the bad input tune to both of these input circuits. The output side is a flat response. It's designed to basically respond roughly to the 0 through 30 megahertz signal response of the transistor, but it does it in a flat tune. The output filter board has got switched stages for each one of the bands, and the output tune changes accordingly to the frequency. This is a low pass filter, a switchable low pass filter. That's all it is. Okay, so it lets the lower frequency pass, but it notches all the upper frequencies, and that's really what most and the FCC actually pay attention to, right? So if I have this on the 160 meter position, everything above the 160 meter band frequency is cut and nulled to ground. Okay, that's 160, and then we go down 160, 80, on down 40, 20, and then 10, 15 and 10. Okay, so the 160, we're operating this on 80. So I thought, you know what, let's just see if we can get it working by going from 160 to 80. We'll go on up to, take it on to 40 meters, and that'll still let 80 pass through, and it started making power. We still had a very high SWR, input standing wave ratio, reflected power, which I don't even like the term reflected now that I really start thinking about how things work. So I got out the contact tool and I cleaned the contacts on the air relay here. They don't even use this anymore, or they don't even exist anymore. The later models had 2 of these 5 amp relays stacked together and fucking blah. Anyhow, cleaned the contacts, and then I started playing with the switch, and I noticed what we actually had happening was a very low voltage 12 volt reference going to the relay. Now watch what happens, how quickly the relay moves when I step on the pedal. What was happening is I'd step on the pedal and the relay would go thump, 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 really slow. And I went, man, we're on a base voltage of 12 volts, right? Why is it moving so slow? So I went over to the RCA connector, and the wire that was going to the RCA connector over here in the back was being held on by the dreams of a third world Ethiopian kid that all he wants to do is get a McDonald's cheeseburger. I went ahead and I redid that solder joint. Now, I mean, are we going to do high-speed RIDI with this? No. Are we going to listen in between the the signals of the dots and the dits at 20 words per minute? Nope, ain't happening. But we've got full function now. Check this out. By going up to 40 meters, yeah, technically from 80, technically the output tune on the filter board wasn't correct, but what I was doing was to see if it was a shot in the dark. I noticed underneath the FLIR that this particular relay, which is 80 meters, was getting up to 95 degrees. It's about 68 in here right now. So for this to get 30 degrees above ambient, I thought, man, maybe the output network, this relay or this relay has gone bad. And I thought, well, if that's the case, all I got to do is switch bands. The RF will have a path to go through, and that'll tell me if the expensive bit, the transistors, are damaged, right? Well, no, it immediately started making power. It just had a high input SWR. So, 1 watt in, 35 watts out. So now if I take the radio and come off of AM, sideband, turn the power up a little bit. Hello, 1, 2, 1, 2, 1, 2, 1, 2. So we're getting our 500 watts at 12 volts out of it now. And our input schwirr, spot on the money. 1, 1, 1, 1, 1, 1. Hello. It's up there a little bit. It's like a 1.1, 1.2. Yeah, a little bit. These amps are really catered to the guys that work 80, 40, and then we start to see the power drop off consistently. And I say this based off of lots of these amplifiers across the healing bench here. So it's been a couple weeks, not a couple weeks, it's been a couple days. Feels like a couple weeks. As you guys can see, we changed this. And if you're watching the videos in sequence, you'll see that the video for this, me bench testing this thing, has already come out a couple days ago. It's actually been out on Patreon now for over a week, so it's been a week or so. Okay, so we're back on the Ameritron project, and I decided that what I wanted to do is that I know that there's something a little askew with this relay. This relay, it was superheating with the FLIR. I could see it. As soon as you turn the amp on, it doesn't matter what band it's in, for some reason that one relay is getting hot. Well, ain't nothing special about that relay. None whatsoever. I mean, we keep a lot of these around here. I use them to just switch 12 volt bias current on and off, that kind of deal. So we're going to go in here and we're going to replace the cheap unknownium. Who are these made by? Schningel, and we're going to replace it with a Panasonic. A little bit higher quality part, but to me, I think the coil is breaking down and it's pulling the voltage low. You know how long I had to work on these things before I decided that I needed to be smart about it and not take the screws off from the top side, but take them off the bottom side of the amp? Makes things a lot easier, I'm here to tell you what. But I went to go pull this out, and I got to disconnect one coax lead to be able to have access to it, and it's the one that attaches to this far left corner. So I go and I lift, I wiggle and I massage and I adjust, and in the process of things, this is purple, believe it or not. This wire is purple. This little purple wire goes blink. Look at his partnered one that's right next to it. And this one here. So MFJ soldering at its best. I swear, the only thing that was making that wire make contact was that it was hooked underneath the board, kind of like this, just like how this one is here. If I was to tweak this wire around enough, it would pop out of here. I mean, like, really, look at this. It's bad. So I thought, well, maybe I should slow down and look at everything. So then your eyeballs start looking at things like this little angel hair that's hanging down. That's 100% of the output of this amplifier. And we've created ourselves a spark gap generator, basically. It could be a reason why it decides it wants to trip on a couple of the bands. There's a put up on 10 meter. I didn't show it on video, but you put it up on 10 meter, this thing wants to trip a lot. So there could be other problems. By me flipping the board over and wanting to replace that one relay, we were able to discover that some of our control interface wires are not hooked up, and we've got this shit going on right here. So we're going to resolder these wires over here. That's an easy fix. We're going to unsolder the one relay, this guy here, and we're going to change it out completely and replace it with a brand new one. And then I'm going to go over every joint on the board. And then I thought, you know what? I had a bunch of these prototype caps kind of floating around here. And I think I got an upgrade solution for some of the parts over here that are known for failing or falling out of tolerance, like these guys. And I want to see how much that's going to affect the operation on things. Then I've had some other ideas, which we'll get to in a minute. I'm covering too much ground here too fast. Let's get this squared away, and let's get the relay swapped out real fast. And yeah, let's get this done real quick, and then we can start moving on to the fun bit. Okay, pardon my reach. I gotta get in front of the camera here, but it's okay. You guys will forgive me. So we've got a couple joints here that were not ever attached, as we know. And as I've been sitting here working on the that's better. So I've been sitting here working on the relay. I've kind of let my eyes wander around the amplifier a little bit. I found a couple other things here that we need to make a little bit better connection on than just these bottom three. Come on, take it. There we are. Take it. There we go. This one's not even soldered in as well, as we can all clearly see. So okay. So now I feel comfortable we can put this back together. I got one other thing I gotta fix, and that's that there. And I'm gonna get in here with a pair of tweezers and pull that out in just a second. That little tiny hair is what we're talking about. But for all intents and purposes, I think that this will be a lot better setup for this guy than what showed up here initially. Okay, now to move on to the fun part. The part I think is fun anyhow. This solder that they use is a little bit higher temp than what the rest of us on the planet use. So we have to go in here and we have to kind of wash it away, and then we got to wait for it to this, we got to wait for this to get liquid. And then we can flow in here, and then we're going to unsolder these parts, even though they're already floating around. Come on, there we go. So now, let's fix this bit, which doesn't have anything to do with anything actually operating, right? So let that flow over and get warm. Grab those with the hemos, the chemostats. Oh, that's okay. So I have seen in my time, the reason I'm doing this is because I've seen this now, and I'm using this kind of as an experimental test bed a little bit, but not so much. I have seen these caps, they'll get hot in some of the modes of operation you guys use these amps in, and they have a tendency to break down. So our grand total of capacitance is 360 plus 820. All right. we're going to replace those with metals. So we're going to take the polymer insulation, we're going to take the plastic portion of the insulation out of the equation, and we're going to use metal capacitors. They have a tendency to put up with more abuse, in my experience. They have a much higher kV rating, and they have a higher temperature tolerance, which means better overall. These OG parts new are $250 now, the Toshibas, so there's $1,000. $1,000 in transistors right there. Or we can use the Chinese transistors at, you know, $35 a piece. But still, why not put two $10 capacitors in the place of these $2 capacitors that we know are going to last and are tried, true, and tested, right? Why would we not want to do that? I mean, it just basic sense, don't you think? Okay, well, all fixed. 10-meter band wasn't working right, and sure enough we had one of these coils that was touching board, so we changed that around, got that fixed. Power plug pole upgrade, power wire upgrade. Added some electrolytics to this one to see if they'd make any difference. It really didn't, but they're here. Went ahead and did a cap upgrade, metal clads. Wanted to see if that make any difference. It didn't, but they're in there and it works, so we're just going to leave it alone. Got the fan punched in the lid, and got the relay repaired. So now the only thing left to do is tie the fan into the case. We went ahead and blued the metal here for the cutout for the Anderson clip, like what we've been doing on the last couple. I just haven't been pointing it out. But yeah, we're all done. This thing works great. I mean, it's 500 to 700 watts, depending on where you're at. It's 450 on 10, and I'll show all that to you as soon as we get the lid put on. But I want to quickly just show the inside of this thing before I go on and put the tin on it and wrap it up. Cleaned the tin up, got a lot of the scuffs and the dirt and the filth off the lid. Made it all shiny again, so it looks a little bit more like new. That's it. Oh, one thing left I gotta do. I forgot one thing. That was to put on the new coax connector. So give me just a minute here. We'll get those switched around, and when we come back, the lid will be on it, and we'll be making power. So what we did is we upgraded the voltage regulator for the fan from a 0.5 amp to a 1.5 amp. And in my opinion, this works better. It's on, off, on, off. Then all we had to do is parry this with the fan that's internal. It runs a lot better in my mind. A lot less moving parts and not relied on a relay. Hold on one sec, guys. Okay, so here we are on 160. Hello, 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 hello. Let me show you drive. Let's get in here. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. My brand new volt amp meter is out to lunch. Anything over 200 watts and this thing freaks out. So that's what I got to spend the rest of my day doing, is trying to figure out how to RFI proof it. But the fan's on. Give it a second. Just a second. I'm moving some air now. I'm here to tell you what. Let's go ahead and go on up to 80 meters. From 160. We're on 80. Radio drive 11. Hello, 1111. Let's go down here. Let's look at the amp output power. Hello, 11. It's 100 watts. Hello, 1111. Let's go over here, take a look at the spectrum analyzer. Start is 0. End is 100 megahertz. Hello, 111111. Nice and clean. So let's go on up from here. Hello, 1 1. Hello, 1 1 1 1. Hello, 1 1 1 1 1 1 1 1. Hello, 1 1. I mean, it's working just the way it should. The question is, how long is the fan going to take to time out? Might have to adjust this, what I'm getting at. And if you get it on your end and you want to adjust it, the potentiometer that's closest to the stock fan is the one that you adjust. This is up for turning it on. It's like if you adjust it clockwise, it makes it turn on hotter. Counterclockwise makes it turn on colder. Come on, don't make a fibber out of me. Gotta adjust this. I'm gonna have to adjust this. Definitely gonna have to adjust this. Come on. By the way, I built you up 3.5 feet, 4 gauge with eyelets on it, heat shrinked, crimped, soldered, the whole 9 yards. Just goes to show you, you adjust something 15 times off video and get it set just the way you thought it would, put the lid on it, it's gonna run a little different. Okay, give me a second. Hello, 1 2 1 2 audio. Success. Okay. Let's see, moving on. What band are we on now? Let's go to 14. Hello, 1 2 1 2 1 2 1 2 audio 1 2. That's working. And now we'll go to like 21 megahertz. Hello, 1 2 1 2. I gotta have something wired backwards in here. It's just tripping. Any little bit of RF and it's just tripping out. Okay, now on up to 10, which is our lowest power output, by the way. 10. Hello, 1 2 1 2. Hello, 1 2 1 2. Here's 10 meters. Hello, 1 2 1 2 1 2. Perfect. I think I had adjusted that a little bit too low. Perfect. Kicks on, moves a ton of air, shuts off. All right, well, let's wrap this dog and pony show up. Well, in conclusion, we got another Meritron finished. It's ready to go out in the world and go be played with and be used and abused and flogged out and go get your call sign called. With the added fan, this thing's just, you can just beat on this thing. It's going to last you forever with the Toshiba transistors in here, which have got a solid 30 years worth of performance history behind them. I don't think you're going to have any problems. RO number 57. It's in the done pile for this year. And now I'm going to go work on making a 12 pill into a 16 pill. So on that note, gentlemen, I want to say thank you all for tuning in. I've got one of these that a customer sent to me for me to use as my test bed hoe and figure out what we got to change, because I honestly feel like we can get more out of this. I don't feel the customer's amp is where I need to be making design changes all the time, so I need to sit down with that thing and make some modifications because I have ideas. But more on that to come. Gentlemen, my name is BBI. If you got any questions, comments, anything I can do to help you out, don't hesitate to give me a call. Big shout out to my Patreon supporters down here. Without them, the world would not go round. We are going to be doing a 4 transistor giveaway in the Patreon group here before the end of the month. So before the end of this week, I hope. I'm going to build a little 4 transistor biased amplifier, and I'm going to have my wife enter in every user on Patreon that's a supporter of me and just randomly pick one and send them an amp. It's the least I can do. These guys support me. It's the least I can do is show the support in return. So on that note, I'm going to run. I appreciate every single one of you guys, and thank you guys for letting me be here to be able to have this job. And if it wasn't for all of you out there in YouTube land supporting me and the radio world supporting me, I wouldn't get to be here doing what I'm doing now. All right, guys, I appreciate y'all. I'll see ya. Click, click.